So Ramesh, you told me what ARM architecture procedure call standard is and why it's important, but can you walk me through some scenarios where it applies? I don't really know what I'm going to do with it.
Well, we said that it's basically listing rules.
Rules.
Right? And if you recall, the rules were four of them. One talks about passing parameters, one is returning parameters, one is obligations, and one is rights. Right?
Got it.
So we know these. So in some way, the rules are almost said like thou shalt.
Got it.
Thou shalt do
That's
this.
why I don't like it.
Yeah, that's what the problem is, right? Now, what we want to see is we want to see what happens if you don't do this, right? That's what really matters, because we want to know what are the consequences of failing, what are the consequences of not following the rule. So let's take some example scenarios. The first scenario we already did. That is, we have an assembly function, assembly code calling another assembly.
Okay.
So we said I do a BL to a fun. A fun is here. The fun expects something, and you have to follow that expectations, right? You have to meet those expectations when you do it. Let's take a second scenario. Let's say somebody wrote some assembly code, right? And let's start with assembly code, and there's a C function, right? Now we can have C calling assembly or assembly calling C. Which one should we do first?
Well, to make it look like the other one, let's have the assembly call C.
Let's assembly call C. And remember that there was an assembler that assembled this file, right? There was an assembler that assembled this, and you used your favorite assembler, and there's a compiler that compiled this. And they're both basically developed independently, but they're now talking to each other. So how does this rule kick in? So let's take a simple function. Let's say there's a function here, and this function again expects two parameters. Let's make it up. It expects a uint 32 underscore t and x, and a uint 32 underscore t y.
All right.
There are two inputs it expects.
And then it returns some value.
And somewhere here it will return, let's say, also returns a uint 32 underscore t. The data types are not significant, so it'll compute something, and it returns whatever the value is, some result that it computes and results.
Got it.
So
what do I got to do if I'm writing assembly and you wrote the fun? What do I got to do to call your function?
Right? So I know I call by saying BL fun.
Ooh,
right? That's what I do, right?
Right, and that can go to C?
That can go to C.
Ooh, nice.
It's a matter of making sure that this symbol exists in this guy's scope. And as long as it exists, the magic happens, right? So I need to do something here, which is I need to make sure that the expected values are in the right place. Right. So if for example, let's take a simple scenario. Let's say I want to call this function. These are what we call as the formal parameters, and I want to pass the actual values, parameters as in values. So I want to call this function with specific values of, let's say, 3 and 16.
Okay. So I got to put 3 somewhere.
I have to put 3 somewhere. So I say I'm going to put 3 into, and we could do something as simple as move s r0 pound 3.
Okay.
And I'm going to do a move s r1 pound 16.
Okay, so now I'm following the rules.
Now I'm following the rule because that is the rule expected.
And what are you going to do to return?
And then I'm going to call it.
Okay, got it.
Right? And it returns something. When it returns something, I know that there is return value. According to this rule, the return value has to come in R0. So now I know that, so therefore I can say, let's say I want to put my result in some memory location. I'm going to do something with it. Let's say it's some important value I want, then I can take it and probably just put it in some location. This is some R1, let's say. I can put it, let's say this is some score or whatever that might be. I can store R0, which is return value, into that location R0.
Okay. explain to me how these other rules would apply. That's the 1 and 2, but do 3 and 4 apply to this scenario as well?
Yeah. So we said that I may have something here. Maybe I have a simple scenario where maybe I have a index. In fact, let's take a very specific scenario. I'm working with this score, and actually I did something here. I did an LDR way up here. I did an LDR R4 comma equals score, and I'm counting on that so that when I come here, I'm going to do an R4. I'm counting on it, and I don't expect you to mess it up.
Got it.
Right? And so that if you mess it up, then this line is going to fail. Right?
Okay, so I'm expecting you to save R4, this compiler to save R4.
R4. And if you don't, then my state gets messed up, and my state gets messed up, then we are in.
So in this scenario, if I had used R1 instead of R4, what would happen?
Yeah.
What would happen? And right there where you had R4, if I made that R1,
if
this one.
This one was
R2.
R2, let's say. Yeah. Now let's take a different scenario, and I made this an R2 instead of an R4, right? And I could use the R2 here. Now,
but
this function, and right now we're looking at this function in C, but maybe this one, because it has writes on R3, it could destroy R3.
Yeah.
Right? Because it has a right to do it.
An R2, you mean?
I'm sorry, R2.
Yeah.
If it destroys R2,
then sunk.
I am sunk.
I'm a bad person.
And so this is something that now this is something that the caller has to watch out for, because if the caller wants state preserved, keep the state in places that are known to be preserved by the callee.
Okay, good.
Right?
Can you show me the other way around? What if?
Let's do a third scenario where C and assembly are like that, and C is the caller and assembly is the callee.
Can I do that too?
Yes, you can.
Ooh, nice.
Again, the rule again is as simple as we have a function here, and the function has a function is going to be called by C, and C simply says fun, and it passes any parameters, and it's going to get the result and put it in something like that. It could do that.
Can you call with the same numbers, 3 and 16?
Okay, let's do that. 3 and 16. And now this guy says that I expect R0 has X and R1 has Y, and he's going to do something with it, and then eventually he's going to put the result in. R0 has the result.
And then what happens after that?
And then he does a BXL.
I got it. Right?
So that's what it looks like. And as long as, again, this symbol exists inside my C scope, the symbol fun, everything works out. That's taken care of by another piece of software called a linker.
Okay, so now, again, you went through 1 and 2.
Yeah.
The parameters are in the registers by the compiler and expected in the assembler. Yeah. But what about rules 3 and 4? Does that apply here as well?
Yeah. So let's think about it. So I made this call here, right? And so now when I made it, clearly I put this one in R0, and this is C. The C compiler is written by a rule following piece of software. So it will put in R0, it will put 3, and it'll put in R1, it'll put 16 before it transfers control here.
Yeah, but what about 2, 3, 4, 5, 6, 11? What about
so
those
it doesn't
registers?
touch any of those registers because they don't come into play because there's only 2 parameters that I'm passing.
But inside fun, what can I do with R2? What can I do with R3?
Totally.
What can I do with R4?
Yeah, so we have every right to mess up. We have at our discretion, we can do anything with R2, R3, and R12. Do not have to be preserved, right?
So I can just play with them all I like.
You may play with them, right? But as a rule, you have to preserve. It says you have to preserve R4 through R11.
So I can use them,
you can
just like I did in the other video, but I have to save and restore.
And restore them.
I got it.
So, so in some ways, these are the classic use cases. In fact, there's one other use case that is that will make more sense to you now.
All right, try me.
So this use case, remember how interrupts work, John?
Ooh, cool, my favorite.
So remember how when I'm executing some code somewhere, am I on this line add s r1 pound 1, right? Boom, there's an interrupt that happened, right? Here, if I'm writing code, I can be conscientious about my obligations, my rights, and everything.
But interrupts come sneaking in the middle of the night when you least expect it.
Exactly. So what do I do?
Yeah. What happens? Yeah.
So what happens when an interrupt comes out of the blue, right? So we know that eventually the control is going to go off to a handler, whatever that corresponding handler is, whatever the interrupt handler is.
And that handler could be assembly or C.
Again, it could be assembly or C.
But how do I get there?
So how I get there is the hardware does the job of saving state, right? So the act of when I go from here to here, now there is we say state is saved, but state or context is defined by the hardware. It decides what the context is. For us on the ARM, again, this is part of the ABI, the application binary interface. It says that it's gonna save R0 through R3 and R12, and it's going to store the link register, the PC, and the PSR. Right? That's 8 registers that it saves. And
is that code or is that hardware?
This is all hardware.
I got it.
Right? This is auto save. This is saved by the hardware automatically, right? And this is our state. So I enter here. Now, once I enter here, again, this guy exits just like before. He does his job, he exits. So he is, after all, another subroutine. He's just like any other function. He's just a function, but he's a function that is a handler of an interrupt service routine. He has
so it has no parameters, so it doesn't matter about R0 coming in and out.
Exactly.
But can I use R4?
So he has to doesn't worry about inputs, but he has to worry about the other rules that he's obligated to follow. And one of the rules is he has to pretty much still preserve R4 through R11 must be preserved. Now guess what? Guess what, John?
Yeah.
What happens if I mess up R0 through R3 and even R12?
Yeah, because I'm allowed to. That's number 4.
Yeah, I can play with that.
Yeah, well, it looks like you pushed it, Ramesh.
Well, I saved them, so the act of returning from here, right? When I return back from here and I get here, all those are restored. So I don't have to worry about them as much as it, because this is an unscheduled departure from my course of action. So you can't expect me to even be worried about those, right? So that's why that the architecture is saving those. All right.